Hello everyone, welcome to our notes on redox reactions. Redox is short for reduction oxidation. So think of it, reduction as reducing, oxidation, we'll learn what that means. First definition we need to go through is an oxidation state. An oxidation state is the charge on an atom if shared electrons in a compound were assigned to more electronegative atom. So it's overall the charge on an atom. Right, so elements have an oxidation state of 0. So all elements on the periodic table, if it's just themselves by themselves as its own atom, it has an oxidation state of 0. So for example, oxygen is diatomic, that is normally diatomic. If it's O2 by itself as its diatomic element, its oxidation state or its charge would be 0. It doesn't have any charge. Zinc by itself, completely by itself, doesn't have a charge, 0. Sodium by itself doesn't have a charge, it's 0, etc., etc. Ionic compounds can be broken up into their ions, and so for example, if we have sodium chloride, we can break that apart, and sodium has a positive 1 charge and chlorine has a negative 1 charge. So the oxidation state for sodium would be positive 1, for chlorine it would be negative 1. Monoatomic ions take the oxidation state of their charge. So things like sodium chloride, right? That is their charge. That's the oxidation state that it is. There's steps for analyzing and writing redox reactions. The first step is to write the chemical equation. The second step is to determine the oxidation state of each atom. So is it a 0 charge? Is it a positive charge? Is it a negative charge? What is its charge? That's the oxidation state. Third step, identify which element is oxidized or reduced. We'll go over what that means. And the fourth step is to write the balanced half reactions. So if we have an example for a magnesium that's burned in oxygen, our first step is to write the equation by itself, right? And so our very first step for that one would be to write the equation. I'll go ahead and do that. So we have magnesium is burned in oxygen. And so we have Mg, which is magnesium metal. Magnesium metal is solid. It is burned in oxygen. We've done this before as our lab. Oxygen is diatomic, so it's O2 and it's a gas. All right, when we burn it together, it becomes MgO. Mg is in group 2, so it's positive 2. Oxygen is in group 6, so it's negative 2. Cross the charges, you just need one of each of those. So it's just MgO. Then we need to balance it, so put the coefficients, right? So we have 1 magnesium, 2 oxygens. 1 oxygens, put a 2 right there. Go back and put a 2 right there. There we go. And magnesium oxide, if you remember, is that white powder at the end of our lab, and it's a solid. All right. Second step is determine the oxidation state or the charge of each one. Elements by themselves are neutral. Repeat, elements by themselves are neutral. So magnesium is by itself, it has a charge of 0. Oxygen is by itself, it's a diatomic element, it's 0. Elements by themselves are neutral. When they are together, they take on the charge of their ions. So since magnesium is a cation when it's with an anion, so we have a metal plus a nonmetal, magnesium's in group 2, so it takes on the charge of +2. Oxygen's in group 6, so it takes on the charge of -2. Right, and when you put them together, they're neutral, which is why we don't write the charges there. Right, step 3 says identify which element is oxidized and which element is reduced. So let's go over what each of those means first. And so oxidation means that the charge becomes more positive. Charge is more positive. The element is losing, because if you become more positive, you lose electrons, because electrons are negative. And in the half reaction, the electron, since you lost it, is a product, it goes away. So the half reaction, for example, is if you have some element A, it loses an electron, so it becomes positive, and that electron now goes off to do something else. Likewise, reduction, the charge is more negative, right? Reduce, think of like subtracting, it becomes more negative. The element is gaining electrons. And in the half reaction, the electron is a reactant. So in our equation, we have some positive cation. We add an electron to it, and then it becomes neutral. Or we could have a neutral element, we add an electron, it becomes more negative. The way that I remember this is Leo says Ger. I'm going to draw a little picture for you guys. So that's Leo the lion. Leo says grrr, right? And so this is just a mnemonic device that I still use to this day to help me remember. Losing electrons is oxidation. That's Leo. So losing electrons is oxidation. Leo. Gaining electrons is reduction. Ger. Gaining electrons is reduction. So losing electrons is oxidation. Gaining electrons is reduction. So going back up to the top, scooch this up a little bit, and then I identify which one has been oxidized, lost electrons, which one's reduced, gaining electrons. So if we look at magnesium, magnesium went from 0 to positive 2. If you become more positive, you're losing electrons. You've lost electrons, so you're being oxidized. That's Leo. You lost electrons, you're more positive, you're oxidized. If you are gaining electrons, you become more negative, and so oxygen went from 0 to negative 2. That one was reduced. It gained 2 electrons, it became reduced. So if we write the balanced half reactions for magnesium and for oxygen, it would look something like this. So we have magnesium, and it became magnesium 2+, and therefore we lost 2 electrons overall, right? The 2 positive, and went from 0 to positive 2. We lost 2 electrons. But remember, there was a 2 in front for this, so this is multiplied by 2, this one's multiplied by 2, and this 2 right here in front of the electrons, 2 times 2 is 4 electrons. For oxygen, we had O2, right? Its charge is 0. We added electrons to it, and it became O2-, right? So overall, we added 2 negative electrons to it. But remember, again, there's this 2 right here, so we need to multiply this by 2, which means this is multiplied by 2, and then 2 times 2 for the electrons is now 4. And that overall makes sense because we have 2 magnesium, we have 2 oxygen, and then the 2 Mg and the 2 O2-, those come together to make a compound. And if we really wanted to, we could cross out the 4 electrons because whatever the same on both sides can get crossed out. And so this top one would be the half reaction for oxidation. The bottom one would be the half reaction for reduction. There's a couple of different examples of redox reactions that can occur. So redox can occur in combustion reactions. They can occur in synthesis, decomposition, and single replacement. So notice they do not occur in double replacement. Double replacement, the charges don't change. The charges stay the same. All right, what I would like you to do is to go through some of these examples. There's 1, 2, 3 examples on the bottom, and just try them out. See if you can identify, write it, balance it, identify what the charges are, and see if it's lost electrons, so it's oxidized, or if it's gained electrons, so it's reduced. The answer key is online. The teacher edition is online. Go ahead and check your answers on that answer key on the teacher edition notes. And last but not least, we have single replacement reactions. Those are the ones that we're going to be looking at the most for redox, for reduction oxidation reactions. It's sometimes called a push-out reaction, where the element becomes an ion and the ions become an element, right? So I'm going to highlight that. It's driven by an exchange of electrons, so you're losing electrons or you're gaining electrons. And it takes place between an element and an ionic compound, right? That's just the definition of a single replacement reaction. There's 2 subtypes. There can be a replacement of a metal. So A and B are metals or hydrogen, right? And that A is more active than B, and so they replace each other. This right here is called the activity series. So if Lithium is more reactive than potassium. Potassium is more reactive than barium. Barium is more reactive than strontium. Strontium is more reactive than calcium, etc., etc. So if you are a more reactive metal, you will replace the other metal. You do not need to memorize that, by the way. For number 2, it says replacement of the halogen, right? You can replace X with Y, you can replace Y with X. So X and Y are halogens in this case, and X will be more reactive than Y. And this right here is the activity series. So fluorine will replace chlorine, chlorine will replace bromine, bromine will replace iodine. So again, try out the 3 examples right there. Check your answers on the teacher edition. Write any questions down that you have questions on. Where are you getting confused? Where are you getting stuck? And then ask them in class.